Hey there, it's Jason from Codemanship with another video diary entry. Please like and subscribe and ring the bell for notifications if you're enjoying these videos or finding them useful. Okay, now, I recently posted a video asking if developers should seek permission for refactoring. It may come as no surprise to you that I don't believe they should. And opinions differ quite widely on this. And there's all sorts of reasons for that, I think. I've worked with a lot of developers over the years. But I think very often what it comes down to is it's a kind of mismatch of expectations about what we mean by refactoring, and particularly the granularity of that word. The size of the changes of the code that we're talking about when we're talking about refactoring. So what I want to do in this video is just discuss that in a bit more detail, but also to demonstrate what I mean by refactoring, so that can calibrate your responses as to whether or not you think at this level it makes sense for developers to seek permission to do refactoring. And I'm going to illustrate it using the Mars rover cutter. So I've got a working Mars rover. The design's not great, but it does work, as evidenced by tests. Tests, as you'll see, really important in refactoring. I'm just going to rerun my tests, make sure they're all passing. Okay, now, refactoring, in terms of its dictionary definition, is rewriting or changing the internal design of software, or improving the internal design of software, I should say, without changing what the software does. And that's a very generic, very general way of describing it. And many developers, when they think they're refactoring, that's kind of the level they're thinking of. Well, I'm rewriting the software and I'm not changing its behavior, so I must be refactoring. But there is a discipline that comes with it. Refactoring is supposed to be safe. That is, we keep the code working as much as possible. And that has technical implications. It means that when we're rewriting the code, we're doing it in very small atomic steps. And after each step, we're retesting the code, very importantly, to make sure that we haven't broken it. So I'm going to demonstrate some refactoring. I'm going to do one manually to begin with. But we also talk about the motivations for refactoring and how often you would expect to be doing this. Now, as a developer, I refactor pretty much continuously. I'm refactoring all the time. If I'm doing test-driven development, for example, the third step in that TDD cycle is you stop, you review the code, and if necessary, you refactor it. So you're going to be refactoring many times an hour, which means you're going to be retesting it many times an hour as well. It simply doesn't scale at that level to have to seek consent to do that, either from the team or from a manager. It simply doesn't make sense. It doesn't scale. You have to be able to trust developers to make good refactoring decisions and have good refactoring instincts and motivations, as well as good refactoring discipline. So we'll talk about the way that I refactor and the way that I coach and train teams to refactor that hopefully gets around some of the objections about requiring developers to seek consent to do it. But let's start by just demonstrating what it is. So I've got what's called a long method here. The execute method of my Mars rover takes a sequence of instructions and executes each instruction in turn. It's a long method. It's doing too much, basically. It's too long, too complicated, and also a little difficult to understand because we can't, what is that block of code there doing? What is that block of code doing? And so on and so forth. So there's some design problems here that we'd like to fix. So my goal here is to refactor this code, refactor this method to make it shorter and easier to understand. That's my goal. And I'm going to do that by extracting each of these blocks of code inside each of these if statements, each instruction, refactor these by extracting them into their own methods, and I'm going to use the name of the method to document what that block of code is doing. I'm going to do the first one manually because when I say atomic rewrites, hopefully you'll get an idea of what I mean here. When we make a change to the code, let's cut that. This code is now broken because it's not turning the rover to the right anymore. So if I were to run my test now, some of them would fail. So we're not done with this rewrite of the code. We're only done when we get back to seeing it work again. So to make it work, I've got to do more. I have to call the method that turns the rover to the right. That means I've got to declare that method. It has to exist. So let's create a private helper method. And then I need to paste in the code that was doing the work so that it is turning it to the right when we call that method. So that is a single atomic step. That's a refactoring called extract method. It's the simplest example of it. And once I've done that, once I think I'm back to working code, I need to immediately rerun my test, which is why it's so important that your tests run fast. That's super, super critical. So all the tests are passing. That's good news, but we ain't done yet. Now, safety, the other part of safety is our ability to get back to something that works, or to get back to the last design that we were happy with if our refactoring experiment at the wider level goes wrong. So you've got certain levels, quite powerful undo features within your IDE probably these days. But if you want ultimate undoability, maybe get into the habit of committing on a frequent basis and label those commits, have commit messages that are very descriptive as to what you did. Extracted write method from rover.execute. Oops, xi. So ultimate undoability. So this is the safety aspect of refactoring. However you do it, you want ultimate undoability. Treat everything as an experiment, and experiments can fail. They can go wrong. Okay, so we've done that. Let's commit that. So far, so good. So it's like a gamer saving the state of the game before they attempt the next obstacle, the next part of the game. Okay, so we've got this very similar looking code here that turns the rover to the left. Now this time, because I'm using IntelliJ and we have a very comprehensive suite of automated refactorings, I'm going to use the automated version of extract method to do this, so it'll do all the donkey work for me. Basically, it'll do it as a single atomic step, but do all of the work. Excuse me. So this one turns the rover to the left. Okay, we get a little preview of what's going to end up there. That looks good. It's trying to be clever here and trying to make this method reusable. Don't be clever. Just do as I say, IntelliJ. Thank you very much. And again, I've done a single refactoring, so immediately back to running the test. And of course, if I'm going to commit this, I won't commit it until I've seen the test pass. That's another real discipline, which is only ever committing stuff that works, basically, and certainly never pushing or merging code that hasn't been tested. Okay, and then we're back to Git. So we extracted a left method from over execute. So I'm being super descriptive here about what I've changed and where I've changed it, so that I can recognize where I am in the process if I need to go back. Okay. So far, so good. And we need to keep going. So here's the code, the block of code that moves the rover forward 1 square. Let's put that in its own method and call that forward. So the names of the method essentially are the comments that I would have written if I was commenting this. So we're making the code self-commenting, self-describing. It describes what it does. Okay, and again, one single refactoring. So this is where I think I part company with a lot of developers. A lot of developers talk about refactoring, but they're not applying this discipline. They're not taking these small atomic steps. They're not continuously running those tests. They're not adding safety with, say, for example, version control. So they can, if it goes wrong, they can get back easily. And again, let's put our seatbelt on. And this is super methodical, yes, and that's what refactoring is supposed to look like. We extracted a forward method on rover.execute. So what did I do and where did I do it? Okay. It would be interesting to see if someone could rig up a tool that actually generates the comments from the sequence of refactorings you've done if you're using the automated refactorings. And then finally, this one here moves the rover back 1 square. Oops. All fingers and thumbs this morning. Okay, move the rover to the back. Don't be clever. Okay, And again, before I do anything else, immediately rerun those tests. And that's why it's so important that the tests run very, very fast, because you're going to be running them a lot. So you do a single refactoring, that's an atomic rewrite of the code, like extracting a method, introducing a parameter, extracting a class or an interface, so on and so forth. They have very well-defined mechanics. And then you do the larger refactorings, like breaking down a large method into a composed method or a more composed method. Those larger scale refactorings are executed as a sequence of those small refactoring primitives, I call them. The refactoring primitives that have those well-defined mechanics. And so that you can test and test and test and test. You're never stepping really more than a few seconds away, ideally, from working code. So the code is working most of the time. If the code is working most of the time, that means the code could be merged into the trunk whenever you want, which means the code could be shipped whenever you like. So you're keeping your code shippable. But there's other big advantages as well. The more code I change, the more changes I make before I retest the code, the more likely it is that I break it at some point, and then it's much harder to figure out where I broke it, and it's much harder to get back to something that works. Now, if I revert an hour's work, that's a pain in the you know what, or a day's work, that's a big pain. And the more you go without retesting, the longer you go. It's kind of what they call the sunk cost effect. The more time you spend on the refactoring before you find out that you've broken the code, the more reluctant you are to say, okay, well, let's revert that and try again. Which is why we tend to end up, when developers go too long before retesting, with broken code being checked in, because they don't want to let it go. They're trying to fix it, basically, rather than just throwing it away and starting again. So refactoring is super disciplined, it's super methodical, it's designed to keep you safe, to keep you very close to working software. Those fast running tests are really, really important in the process. I need to do my little commit now, so let's go back to the terminal. Doesn't want me to go back to the terminal, it's busy doing something. Why won't you take, there we go. Okay, git commit, and oops, I said it's early in the morning here. Extracted back method dot execute. Okay, and off we go. Now, I've made some structural changes to the code, and this is where I think the other objection people have to developers doing refactoring solo by themselves without consent from the team or from a manager, and that is the level of granularity of changes at which refactorings are shared with the rest of the team. Now, it's a very common experience. We probably all had it at some point. You've got that one person on the team who says, I'm going to do some refactoring, and they go away and they refactor for days or even weeks, and they're not checking their changes in. So the rest of the team is blissfully unaware that the structure of the software that they're working on, the ground beneath their feet, is shifting and changing. So you spring, it's really bad form, really bad protocol to spring large-scale refactorings on a team in one go, because it totally destabilizes the team, basically. The structure of the code they're working on has completely changed. So you get some real train wrecks with those kind of mergers. So also get into the habit of merging your changes into the trunk branch, the release branch, to share with the rest of the team, basically. The branch the rest of the team are working to eventually on a pretty regular basis as well. So I might at this point think, well, I might flatten all those commits. If there's lots and lots of commits, I might flatten those into a single commit first. And then at that commit, I might document what I did there at a higher level, like refactored execute method into a composed method. So we know at a higher level what was the goal there, what did I achieve. And then I would push that, or if you're working on branches, I would merge it to the main branch, so that the rest of the team can see a small number of changes that I've made. I'm drip feeding this refactoring to them. So that we're not constantly tripping each other up, but they're also getting a chance to review my changes. So if they're not happy or if there's a problem, I haven't changed that much. It's much easier to fix. If I went away for days and did wholesale refactorings and then sprung it on the team, then it's too little too late at that point to review it. That's a general problem with code reviews and pull requests and that kind of Git flow. So I think it's because of the way that I refactor that even if the goal is a high-level goal, maybe a major structural change or a major re-architecting, I would approach it in such a way that it would eventually just be a sequence of small atomic refactorings that maybe at a slightly higher level are being drip-fed to the rest of the team, so they're seeing it on an ongoing basis. It's a work in progress. I have many opportunities to object or to fix things or to talk to me. But also on that subject of code review and getting consent from the team, or consensus maybe is a better word for it as opposed to consent, because assent implies someone has the power to tell you no. Consensus is a slightly different thing. It's more not the word meritocratic, more, what's the word I'm looking for? Egalitarian, if you like. We're all equal, but we're seeking, it's more democratic, if you like. I think that's a good word for it. So I prefer that. Now, if you are worried about developers going off and making bad decisions or refactoring code for no reason, which is one of the objections that was raised, then there are ways around that with continuous review. For example, pair programming. If you've got junior developers and you're thinking, well, I'm not sure we can just leave them to make these kinds of decisions, then maybe put them with someone with more experience, or pair them with the architect, or pair them with someone who knows what they're doing. But don't let them work on their own. Or maybe ensembler programming, or mob programming as it used to be called. Get that. If you want consensus from the team, maybe the team should get together on this kind of important refactoring. So you seek permission not by saying, am I allowed to do this, but by saying, okay, I'm going to be doing this major structural change or this major re-architecting. I think we should do it as a team. And then we can have those discussions and disagreements in the room while we're working on the code. That scales. What doesn't scale is having to go up the chain and seek permission, or having to go to the team and have a vote on it constantly, because the team are working on other stuff. So you can't have it both ways. Either there is someone sitting next to you or people in a room saying, okay, yes, I think we're happy with that, continuously throughout the work. Because you see the level at which I'm doing it it's a pretty low level. I'm refactoring many times an hour normally, and it simply doesn't scale for me to then have to go to my boss and say, is it okay if I do this? Is it okay if I do this? Is it okay if I extract this into a shared class? The boss has to trust that I will make good decisions. And on the off chance that I don't, I need to be sharing my work, sharing those changes on a pretty regular basis with the rest of the team, so they have many opportunities to raise objections or for us to fix misunderstandings or problems before I go too far. That's very, very important. So the other thing that often trips teams up when it comes to the granularity of refactoring is, well, let's take a look at some legacy code. Got a bit of legacy code here. We've got this thing that basically manages stock of products when we're selling the products. Don't need to worry too much about what it's doing. What you do need to know is it's legacy code. According to Michael Feather's definition of legacy code in his book, Working Effectively with Legacy Code, highly recommended, by the way, legacy code is code that does not have fast-running automated tests. One of the biggest things that makes code risky and expensive and difficult to change is how soon we would know if we broke it. If the answer is days or even weeks, we have a major problem. But even hours, or even 20 minutes, or even 15 minutes might be a problem. Particularly when it comes to refactoring or restructuring code, because as you've seen, fast-running tests are kind of essential. So what do we do with legacy code? Now, most developers are working on legacy code most of the time. Most code out there has either poor tests or slow tests or no tests. And therefore, refactoring is very difficult. How do you refactor without those fast-running tests? Well, again, now this is where you need to be super, super disciplined. If I were to refactor this legacy code here, which has these hard-coded calls to web services, so it's not unit testable at the moment, if I'm asked to make a change to this logic, and this is the only reason I would refactor code, is because I need to change it. It's either code that I am writing now, which is changing as we speak, like in test-driven development, or it's code that I've been asked to change, and then I would target my refactorings to make that change as safe and as easy as possible. As Kent Beck puts it very eloquently, make the change easy, and as you're about to see, that might be hard, and then make the easy change. So before I start noodling about with this product solve method on my stock monitor, I want to be able to write unit tests for it to make that change process safer. I'd like to be able to make the change I've been asked to make in a test-driven way. But I can't because it's not unit testable because it's got hard-coded external dependencies. So this is where you need to be super disciplined. I identified this is the code I want to change, but I need to make it unit testable. So I need to refactor this code to make it unit testable first of all, and then write unit tests for it straight away. But I don't have unit tests, so how can I safely refactor it? This is where the discipline comes in. Even if you have to test it manually, you still need to retest it after refactoring. Don't go for hours and hours on legacy code and then test it just because testing takes a long time. You need to, for that part of the software, so you don't necessarily have to test all of the software, but maybe for that part of the software, figure out, well, what features might this break? And therefore, I will need to retest those features and maybe write little test scripts. I've actually got a command line script that I can run that will do a little sort of system test for me. So I'm going to be using that, but I'm still going to be retesting. So I need to break this dependency in order. So I've been asked to make a change to the date range for the sales history of the product that we're selling. At the moment, we're looking at the previous 30 days of sale. The business would like us to look at the next 30 days from the year before. So we're looking ahead instead of backwards because sales are seasonal. Now, I need a product that tells me how much stock we've got and so on and so forth. But I don't want to get the product from the web server. So what I'm going to do is I'm going to extract this into its own method. Get product is a reasonable guess. Thank you, IntelliJ. And now that I've done that, that's a big enough change to make me nervous. So I am going to retest this. So let's go back to we've got a program here that I can run with a couple of test data arguments, a product ID and a sale quantity. And we should get a message telling us to restock this product. If it's working, we should get a message saying restock this product. You need to reorder product 811, only 27 remaining in stock. Lovely. So it appears to be working from that system test. Pain in the you-know-what to have to system test it, but trust me, the alternative is far, far more painful. Okay, go back to our stock monitor then. So now it's in its own method, but we still have the same problem. It's a private method. It's still calling the web service. So what we really want to be able to do is to substitute an implementation of this method for a different implementation. For example, one that's generated by Mockito that will return a test product, a product that we hard code in our test. So I'm going to do a refactoring called extract delegate. And that's basically extract class. It extracts members of a class into a new class. And I'm going to call this the warehouse. So the warehouse is where we get the product from. Okay. And you'll see what it does when I do that. Let's add that. Okay. So it extracts a new class called product warehouse, which goes to at the moment is going to the web service. And then it creates an instance of that warehouse, which we can then use instead of calling the getProduct method here. It creates a delegate method so as not to upset any client code. But in actual fact, we don't need this. So I'm going to do 2 refactorings in a row because this is a very small refactoring. Let's do 2. So let's inline that because we don't need it anymore. But after those 2 refactorings, I'm still going to retest it, even if that means running it and clicking the buttons myself. It's much safer and better in the long run and usually quicker to keep testing it, even if you're testing it manually. Now, you'll see there are people out there, people who actually do training in refactoring who say this, and I'm afraid it's not true. There are some people who say, oh, if you use the automated refactoring tool, you won't need to run the tests again because the tool is guaranteed not to break your code. Exhibit A, the tool has broken my code. So it's not true. You do need to run it. So let's fix that problem and run our test and make sure. This is why you don't want to stray too far from, even if it means manual testing, stray too far from seeing tests pass, from seeing the code that you're changing work. Okay, and there's another couple of things we can clean up here. So we don't really need that. So let's do that while we're in here. And again, even though it's a pain in the you-know-what, we still retest because the alternative is the debugger. And potentially hours and hours or even days of lost work. Okay, back to our stock monitor. So we now have an object, the warehouse, that goes to the web service, but it's still a hard-coded dependency. So let's fix that. And let's start by initializing the warehouse in the constructor. And again, I'm taking slightly wider steps here because of the overhead of retesting. But again, you don't want to go too far, do too many refactoring. So I'm being slightly less disciplined on this front, but that's because I have to be more disciplined about running the tests. Okay, let's introduce that as a Let's introduce that as a parameter. So the warehouse is being passed in from the outside. So we now have the warehouse being dependency injected into the stock monitor. And that's our seam in our design, as Michael Feathers calls it, where we could replace the implementation of warehouse with a different implementation. For example, a stub, maybe using Mockito, that returns a hard-coded product for the purposes of testing the date logic. Okay, and we've got a similar problem down here with the sales history that's being fetched from another web service. So we might then say, well, let's extract the code that fetches the sales total from the web service, all of that code there, into its own. In fact, let's just do it. Probably much simpler. So the actual dates are, that's the bit we're interested in. That's the bit we want to change. The rest of it, let's extract that into a method. Okay, sales total sounds reasonable. And let's retest. That's a big enough change that it could have gone wrong. And while I'm here, I think let's move. So end date, start date doesn't sound right. So while I'm here, let's fix that. Make it start date, end date in the signature of that method. So it makes a bit more sense. And retest it. So I'm being super disciplined. You can imagine with more complex software, with maybe going through a real UI rather than a command line, what a real pain this might be. But we want to live with it for as little time as possible before we get to a point where we can write unit tests. Okay, now let's extract this into its own method, into its own class. So use extract delegate. Let's call this sales history. Okay, hopefully that will do it all in one go. And we should, first of all, immediately take a look at our sales history. Yeah, broken. So let's fix it. And then back in our stock monitor, while we're here, let's just get rid of that auto-generated delegate method because we're not using it. Okay, and retest. So in this little demonstration over the last 20 minutes or so, 25 minutes, how many times have you seen me retest the software? And that's the essence of the refactoring discipline. And as I said, that's where me and a lot of developers part company because they've never done that. Their vision of refactoring is at that higher level of granularity. It's much bigger structural changes before they retest it. And of course, at this point, I would be committing and doing other stuff as well. So now we've got our sales history. Let's initialize that in the constructor. And we'll do this as a single step. Let's introduce it as a parameter. Okay, there we go, and retest. So now the warehouse is dependency injected. We can swap that for testing. Sales history is dependency injected. We can swap that for testing. So we can now write a real unit test for the date logic that would allow me to change the date logic in a safe way. We could probably reproduce the test we've got as well, maybe using a mock alert to check that the alert is actually being sent when it should be sent. So we can write unit tests for the logic of products sold that don't involve visiting websites. So we've separated those concerns. So even if you're working on code that has fast running tests, good tests, hooray for your side, that's a win. But if you don't have it, then as a priority, you need to get it by hook or by crook, and you need to be super disciplined in doing that. and making that part of the code unit testable. So it's a question of granularity. And at the granularity that I refactor those small atomic rewrites, it makes no sense. It's completely impractical to expect me to seek consensus. We can use continuous integration to make it so that we don't go too far before other people on the team see what we're doing. We're not springing large-scale or wholesale restructurings on the team in one go. We keep running those tests over and over again so we don't go too far from working code. And we can use version control in whatever form you have it for ultimate undoability. So if it goes wrong, getting back is really no big deal, and we haven't wasted a lot of time. But very importantly, we keep that code working. That is the discipline of refactoring. Small micro iterations, those atomic rewrites, then run the tests, and then another refactoring and run the tests, and then another refactoring and run the tests. And gradually you can completely reshape the code, but you're not doing it in a way that's going to come as a surprise to the team. If you are worried about whether or not you trust developers to do this or to choose when to do it, then pair them with people who are better at those decisions. And if you haven't got anybody you can pair them with who's good at those kind of decisions, then you have a very different problem, my friend. So I would work on your hiring and on your training. Work on training your developers perhaps and coaching them and mentoring them to build them up to a level where they make better design decisions, particularly learning about design principles and code smells. That goes hand in hand with refactoring. And refactor with a purpose. Refactor to accommodate the changes you're currently trying to make, the code that needs to be liquid because you're actually working on it. You're shaping that code right now. Don't have refactoring sprints or refactoring phases. The results of those are always very disappointing. And again, they give refactoring a bad name, and they're usually the reason why people need to seek permission to do them, because you're making it the business's problem. Whereas when I talk about refactoring, I'm talking about this continuous low-level activity. It's very, very disciplined, and is also can be done in a way that is very team-oriented. And that's how I would encourage you to do it. So this is why I don't believe developers need to permission to refactor, because probably when I say refactor, it means something else to me than it does to a lot of other people out there. Anyway, that's the video diary entry for today. The sun is shining. Hope you're well. Stay safe until the next one.